So we're now ready to start describing a case study that'll apply the various operators we've talked about in Flux so far. This is case study ex1. And as you can see, it's going to apply all the things we've been talking about. And it'll also show how to use the mono from callable operator to get things to be get things to be lazy, not eager, the reverse of eager, lazy. And as usual, you can get all this stuff in my GitHub repository at this link. We're now in the IntelliJ project for case study ex1. Let's first take a look at the ex1 class itself. This, as usual, is the main entry point into our test program. And you can see what it does is it goes ahead and registers a bunch of test methods, test fraction multiplication sync1, sync2, sync3, and then one called test map not null. All of these are synchronous calls because we haven't introduced subscribe on yet, although you could probably figure out what it did if I was to show it to you, but we haven't got there yet. So we're going to use the async task barrier just because we always do it, but it's a little bit overkill here because these things are all going to run synchronously. So we're going to have this run, we're going to have it block the main thread, but all the processing we're about to see is all going to take place in the main thread of control. And in fact, we won't actually get to block until everything's done, so it won't block for very long. So now that you've seen that, let's go ahead and take a look at Flux EX. That's where all the fun happens. And let's take a look at each of the different test methods. So here's test fraction multiplication sync1. It's going to use a string builder to keep track of the logging output because there's only one thread of control. So why not? No sense having a thread safe object if we don't need it. So down here, we're going to use Flux the just factor method to create ourselves a stream of big fractions. This kind of came right out of the slides. Everybody has a numerator of 100 and a denominator that goes 3, 4, 2, 1. So that creates that Flux stream. We then use the doOnNext action operator, and we're going to go ahead and append into the string builder the thread ID followed by the mixed string version of this thing, followed by what we're going to be multiplying things by momentarily. So that's just like a logging output. That's what doOnNext is good for. Then we go use the map transforming operator, which will multiply each element in the stream by a constant. And you can see here we're going to multiply by this S big reduced fraction, which is just a big reduced fraction as the name implies. So we're going to multiply each of those elements by this constant. And then we're going to use subscribe. So subscribe is what's going to set the wheels in motion as always. And you can see here that the consumer, the one that handles each next operator, each next value that shows up, is going to append the mixed fraction version of the multiplied big fraction, and that'll put it into the string builder. So we'll be ready to print it when we're done. If for some strange reason, which is not going to happen in this case, we were to have an error, then we would append whatever the error message was, which is going to come through as an exception, and then we're going to display the results because we do want people to see what the results were even though we had an error. And then the final thing is if we finish normally, then this is the runnable hook method that gets called back, or the runnable lambda expression, and you can see what it does in this case is it converts the string builder to a string and then displays that, and then display just prints out the thread in which it occurs. And I'll go ahead and run the program. It won't take very long at all to run because everything's done synchronously. And you can see here that everything is occurring in the main thread of control. The main thread of control is thread 1. So all the things that we see down here are all occurring in the main thread. And everything, that of course means everything is synchronous. So here's the output we get for calling test fraction multiplication sync1. All right, let's move on. Now we're going to take a look at test fraction multiplication sync2, which is not dissimilar to test fraction multiplication sync1, except we're going to use some different factor method operators here. So in this case, what we're going to do is we're going to use the list of factor method to make ourselves 4 big fractions, and we're going to store those things into a list. So now we have a list of big fractions. That's not even, I guess that's mildly functional programming, definitely not reactive programming. Then we come down here and we use the from iterable method, passing in the big fraction list. So the big fraction list had those list of 4 big fractions, and then we go ahead and turn that into a Flux stream of big fractions. And then we go ahead and do basically the same things we did before, except this time we're going to use a helper method called log big fraction, which just does the appending in a more abstracted way. And we're going to multiply things. That really is pretty much the same as before. So this code is identical. The actual semantics of this code is identical. We get the same results. But the way in which we do it is ever so slightly different. And really the main difference here is we just used a different factory method. We used from iterable, whereas before we'd used just. From iterable and just are also both eager. Let's go take a look at test fraction multiplication sync 3. Again, just for the heck of it, we show yet another factory method. This is the one that uses an array. So up here, we go ahead and make ourselves a big fraction array. And the big fraction array contains 4 big fractions. They have the same values as they did before. And then really, we're going to do 2 different things here. First, we're going to use flux from array as the factor method to convert our big fraction array into a flux of big fractions. That's one ever so tinily slight difference. But then we're going to do something much cooler here. We're then going to go ahead and create a second flux called F2, and that's going to use flux from. Remember, flux from are lazy, and flux from in turn is going to use mono from callable, which is lazy, and that's going to go ahead and make a random big fraction using our ever popular make big fraction factor method that makes a giant big fraction. And what we're going to do is we're going to make one call to from, and then we're going to repeat this thing 4 times. So that'll come back to give us 4 random big fractions without having to repeat that code. We use the repeat operator instead of having to repeat that code by cutting and pasting it or putting it in a loop or whatever. Then what we're going to do is we're going to take the contents of flux F1 and the contents of flux F2, and we're going to merge them together. Now, as you'll see here, because of the way we do this, it's actually going to concatenate them in terms of what we get as the output, but that's just a quirk of the implementation. It doesn't have to be that way. So once we merge those things together, then we go ahead and log them, multiply them, and use subscribe to start everything processing, and we do all the work. So let's just for kicks, let's go take a look at what we get as the output from that. So that is test fraction multiplication sync 3. And you can see here that we're getting some diagnostics here. Everything's taking place in thread 1. These are the values we're getting for the big fractions that come from the array. So these are the values. And they're actually the same identical values as we had earlier because it's the same thing. But then down here where we did that random big fraction that was very large, and we repeated it 4 times, you can see what we get. This is going to happen 1, 2, 3, 4 times. And now you can see we've got these absolutely gigantic big fractions. Why on earth you'd ever want a big fraction that big is beyond me. But if you're ever in a situation where you need arbitrary precision big fractions, this is the place to go. So you can see that we now have these gigantic numbers, and those are then going to be merged together, and then that's what we're seeing here is the displayed results of all these things. And you can see that it does in fact concatenate them because all the small ones occur first, followed by all the big ones. It doesn't interleave them. So the default behavior of merge with is basically concat with, but there are circumstances under which they could be different. So if you want concat with, do it. This would probably work fine with concat with. But if you want merge with semantics, then use merge with. Okay, one more operator here, and that is test map not null. And this is going to be kind of a fun example. So now we're back to just using the good old-fashioned just method and do on next. But now we're going to use map not null. And map not null is going to do the following. And you'll notice I did a little tweak here because I created one of the big fractions to be the numerator 100 and the denominator 10, which of course when it gets reduced will be 10. So down here we do map not null. We take each big fraction and we see, does the big fraction equal the constant 10? There's a constant 10 that's part of the big fraction class. You can see there it is, constant 10. And if it matches 10, we return a null. Otherwise, we return whatever else the big fraction was that was not the value 10. Everything else is exactly the same. We print the results. And when we go look at the run of this thing, you'll see that what we're going to end up with here is we're only going to end up with 3 results output, because the one that equaled 10 was skipped by Map Not Null, because I had cleverly converted the, whenever it equaled 10, I returned null, not some non-null value. And so Map Not Null will not perpetuate that null any further. And this will turn out, the reason why I'm telling you all this may seem esoteric, there's situations in your next programming assignment where you have to handle nulls. And the way you've been doing it heretofore is you've been doing this filtering out nulls, because you can filter out nulls in the context of Java streams. Because you use like filter objects : not null or non-null or whatever it is. When you get to Project Reactor and RxJava, for some God knows why reason, nulls are not considered valid values, so you can't filter them. Don't ask me why. So this is what you have to do instead. Okay, so that's basically a walkthrough of case study ex1.